Hello everybody and welcome to the next video where we will dive deep into the topic of Autothrust from the subject of instrumentation. So all the questions that you'll see are the most recent questions from across all EASA authorities from ATPL exams. So we will go through all 6 of them, and we will discuss the questions and the answers in a bit more depth. So without further ado, let's jump into the question number 1, which states, what might Autothrust do in turbulent or wind shear conditions? So what will the Autothrust do? Here, of course, this is referring to very windy conditions where our airspeed is fluctuating, it's going up and down very quickly and rapidly. In such cases, the Autothrust will try to maintain constant speed and will continuously increase and decrease the thrust, which will cause oscillatory increases of these values, which is never really desirable. This is why Airbus, for example, recommends that in turbulent and strong wind conditions, it is recommended that if these oscillations occur, it's best to turn off the Autothrust and maintain constant manual thrust, which means that in these conditions, it could overcompensate, causing oscillatory increases and decreases in Autothrust. For question number 2, you encounter severe turbulence. What are your actions? So this is a very, very similar question to the previous one. Of course, in this case, like we discussed, the Airbus recommendation for Autothrust would be to disconnect it. And although I do not know what exactly the Boeing 737 procedures will be, I will assume that it's exactly the same. And also EASA wants us to associate turbulence and strong wind conditions with high thrust oscillations or throttle oscillations, which in turn force us to turn it off and take the power manually to apply small changes to prevent overspeed or in some conditions stall. However, once you set the manual thrust, these oscillations will essentially stop. And also at this moment, it's good to revise very quickly the differences between autothrottle and autothrust, as these can sometimes be used interchangeably by EASA. However, in reality, they are not. So autothrust is a term that has been coined by Airbus, and this is a system used in Airbus, and autothrottle is used mainly on the Boeing aircraft. The main difference between the two is that autothrust is not connected to the autopilot, and pilots set the thrust levers to a set climb position in which they stay for the whole flight. So the thrust will vary independently from autopilot, regardless of the position of the levers. Whereas in Boeing, the autothrottle will be linked to the autopilots and will try to chase a given value of the autoflight system. And here the thrust levers, the throttle levers will actually move. So it will be easier for the pilots to understand what the thrust setting is at the moment, and also to react if something goes wrong, as it's much more intuitive to see where the thrust or throttle levers actually are. So both systems have advantages and disadvantages. However, this was just something that I wanted to mention at this stage. So for question number 3 right now, if a descent is commenced while the autopilot and autothrust are engaged, what happens to engine thrust? So generally, the most efficient way to descend, and what the system will do once we call for a descent, is that it will reduce the thrust in most cases to thrust idle. And this will call for a constant airspeed. So now, because our thrust is reduced, the nose will start pitching down in order to maintain a given or a set airspeed. And also we can increase the vertical speed in these cases by extending drag devices such as speed brakes, or in some crazy conditions such as the emergency descents, we can also extend our landing gear. And what will this will cause? It will increase our drag, meaning our nose will drop even more down to maintain a given speed, and it will in turn increase our vertical speed, so the feet per minute. So in this case, what happens to engine thrust? And of course, the thrust will automatically reduce usually to idle, and then once we reach the altitude that we selected, the thrust will slowly start to increase, and the nose will start pointing up in order to maintain a given and selected airspeed. And I'll also note here that this automatic system is much different when we're talking about the vertical speed selected, where the aircraft tries to maintain our vertical speed. Uh, and disregards our actual speed, which, if unmonitored at higher altitudes and over prolonged time, can cause stall. And these questions are very often asked during the EASA ATPL exams. So now for question number 4, with VNAV engaged, the autothrust system uses, and what happens to the throttle levers. So the VNAV system is actually referring here to a Boeing system. So VNAV and LNAV are terms coined by Boeing and used in the out-of-flight system by Boeing. In the Airbus, we do not really have VNAV and LNAV. We would refer to something called managed mode. So we will have a managed climb or managed descent, not necessarily VNAV. And this, of course, means that if we're talking about a Boeing aircraft, then the throttle levers will move because of the autothrottle system that exists with the VNAV out-of-flight system. And here I would, of course, also notice that the word autothrust doesn't fit very well. It definitely should be autothrottle. However, the data inserted it will use the data provided by the FMC flight management computer, which calculates all the profiles, speeds, and takes into account certain constraints. And the throttle lever will move with the VNAV system because this is something linked directly to the Boeing aircraft. And now for question number 5. So during an engine start, the autothrottle, what will it do? Well, autothrottle system or autothrust system will not do anything, as these systems are not engaged until takeoff. For example, the Airbus autothrust will be only engaged once we arm it and we select the thrust levers to the climb detent. And before that, the system will not work. All the procedures that have to do with the starting of the engine and shutting it down will be managed by FADEC. So this full authority computer that is located on the engine will manage the exhaust gas temperatures, the engine start, hot start, the engine shutdown, engine restarts, and fuel flow, and maintain a safe operation throughout the flight and throughout the engine start. So the autothrottle system is not used at all during an engine start and as well during engine restart in the air. These systems are there to maintain a given speed that is selected or calculated by the flight management computers. And question number 6, so the last question that we have here today, which says, an aircraft is on the final approach with gusting wind conditions. What effect might the varying wind speed have on the autothrust system? So like we already said previously, so as you can see, there are many questions that are trying to essentially get the same thing from you. And in this case, we need to find a question which will state that the airspeed variations will cause overcorrections by the autothrust system, and this is the question, the answer that is right here. And also here, I'll also say that the Airbus aircraft has also a system which connects the ground speed of an aircraft, which is taken by the GPS with the computer, and the ground speed mini, it is called. It will try to maintain a constant ground speed instead of the IAS if we have these very, very gusty winds. So this system is very smart, and it will allow you to fly a very smooth and safe approach, even if the winds are varying strongly, as it will mainly focus on the GPS data and the speed that you are flying according to these receivers. However, this will be everything for today. So thank you very much for joining in. I hope this will helpful and that we explored this autothrust topic together. I hope to see you in the next videos, and I wish you all the best with your ATPL exams. And until next time, bye-bye and have a fantastic day.